Unit 4, this is going to be your solving equations for a big chunk of your unit again, because solving equations is not just going to be found in math class, it's going to be found in all of your other science classes. So it's really important for you guys to understand about how you solve for equations. Don't get sort of overwhelmed by like the complexity of this. It's actually not as bad as you think it is. It's just you have a couple of steps you have to follow, and after all, they're all follow the same steps. So let's get started with this one. This one, the first page is just the basic stuff. The idea of solving an equation is that they always involve an equal sign, hence equation. So what you have on the left side basically is saying that is the same as the right side. But instead of having like apples and oranges, you have X's and sometimes other letters. And in this case, you have negative 5m is equal to 35. So basically you have negative 5m is equal to 35. So this side is still the same as the right side, even though this one has m. So you have to basically, the purpose of this solving equation is find a number that fits into m. Like negative 5 something is equal to 35. What goes in here when multiplied to negative 35 is negative 5 gives you 35. That's what solving equation is about. So in order to solve for m by itself, well, since you have 5 m's or negative 5 m's, you just need one of them because you just need one m, one positive m. So you're going to divide by 5 to both sides. Why am I dividing? Well, the reason why we're dividing is that this is negative 5m. That means it's negative 5 multiplied by m. So in order to sort of get rid of that negative 5, you have to do the opposite operation, which is division. So if you divide both sides by negative 5m, the negative 5m cancels out, leaving you with one positive m, giving you negative 7. If you don't know if you're right or not, you can always substitute this negative 7 in here. So if I were to substitute negative 7, negative 5 times negative 7 is positive 35. So the left side is positive 35. This is equal to positive 35. Is this statement true? Is the left side of positive 35 equal to right side of positive 35? Yeah, it is right. So that means you have solved the equation correctly. So number 2. Y over 16 is equal to 14 or to 4. This one is a little bit tricky because that's fraction and nobody likes fractions. One key thing is whenever you see a fraction, this side is fraction, has an equal sign. If we were to make this into another fraction, put this over 1, we can do something called cross multiply. This is only done if you have two fractions, so fraction equal fraction. So you have a number here, 5, I don't know, 4, that's a slanted 4, 4 and 3. Fraction equal fraction, that would work. So cross multiply, y times 1 is y. This is equal to 4 times 16, which is going to be, let me see, 64. Okay, so one thing that a lot of people forget is they forget this equal sign. Remember, it's in an equation. You have to put the equal sign. Next one, 6a negative 4 or subtract 4 is equal to 20. That means the left side is 6 times a number and subtract 4. That is all equal to 20. So what's a number that can go in here to make it 20? That's what you're trying to solve. So in order to get rid of, to solve for a to get your answer, you have to get rid, you have to have your a be isolated by itself. So right now it's not because it has a 6 in front of it and it has a negative 4, and that is all equal to 20. So to get rid of all this stuff, you want to get rid of the constants first, all the adding and subtracting first. So since there's a negative 4, I'm going to do the opposite to get rid of that on the left side. But what I do to the left side, I have to do to the right side. So I'm going to add 4 to both sides. So this is going to be 6a, that cancels out to 0, is equal to 24. To avoid confusion, you can always actually just write this on the side. That means you can write it after plus 4 plus 4. So you're not confusing that with division just like at the top, because what's the difference really between this and that? Aside from the operation itself, it looks really similar. So if you want to put all the adding and subtraction to the side instead of underneath, that might help you as well. 6a, I'm going to divide by 6. a is equal to 4. So that's my final answer. Same thing here, negative 7x plus 2 is equal to negative 19. I want to get rid of the sort of the adding and subtracting first. So I'm going to subtract 2. That will give me 0. But if I subtract 2 on that side, I have to do it to that side to balance it out. So this gives me 0. Negative 7x is equal to negative 21. Divide this by negative 7 because I want a positive x, so x is going to be positive 3. So that's my answer. And then moving on to the next 4 questions, same thing. I have a variable and then an adding is equal to something. I want to get rid of all the adding and subtraction first, so to do that, I'm going to do the opposite. So I subtract 4, so that cancels out, leaving me with 2n is equal to 200. So after that, I have 2n's, so 2 times something is equal to 200, so I can divide by 2, n is equal to 100, so I can cancel this. So anytime if you want to check your answer, you can always substitute this 100 back into n, and the left side should equal to the right side. Next question, I'm going to add 4, add 4, 8p is equal to negative 16, 8 divided by 8p is equal to negative 2. This one has a fraction and an add. So sometimes when you get a fraction, don't be alarmed and don't get frightened because I mean it's just the same as before except that this variable is as a fraction. So do whatever you did before. You have an add or subtraction, so get rid of that first. So this is plus 1. I get rid of that by subtracting 1, that immediately gets rid of that. I have r over 6 is equal to 6. I'm going to develop 2 fractions to cross multiply. So drop this invisible 1, 2 fractions and an equal sign, cross multiply. R is equal to 36. Hey, look, I just solved for it, even though it looked like it had a fraction. Same thing for this one. I have fractions plus 10. Get rid of the plus 10 by subtracting. So t over 2 stays the same, but this cancels out. This is equal to negative 16. Again, I have fraction and a numerator, so I'm going to do an invisible 1 to make it 2 fractions and an equal sign. I can cross multiply. So t is equal to negative 32. So simple as that. So let's move on to something more challenging. These ones might involve more than one step because look, I have variables on the left side, variables on the right side. So remember, the key of solving equations is getting the variable to all one side because you want to know what one variable is. So in this case, you have variable on the left and right side. Move them all to just one side. It doesn't matter if you want to move to the left or right. It doesn't matter because as long as they're one side, everything is okay. So since I have the bigger 4k here, I'm going to move the 2k and move the 2k over by subtracting. This will give me a 0, leaving me with plus 4 and 2k. You must be wondering, well, I have this. I was telling you that I need to get rid of the plus 4 or any pluses or subtractions first, but how come I didn't do it for this case? Well, that's a good question because this one is a little bit different because now I have variables on both sides. So instead of subtracting 4, I rather want to get the variables just to one side instead of getting rid of the numbers. In all the previous example from the last page, all your variables are on just one side of the equation, left side, left side, left side, and left side. But since I have left and right side for my variables, I'm just going to move them to one side. So after I have moved them to one side, I solve for k just like how I did before, so that k is equal to 2. Now for this one, it's a lot more challenging because I have variables on the left and numbers on the right, left and right. So same rules apply. Look at this. When you look at these questions, look at, do you have variables on both sides, left and right? Do you have constants left and right? Collect all your variables to one side. So I'm going to move this negative 2q over to the left side. So I have subtract negative 2q here. That means I have negative 5q subtract 7 is equal to plus 23. Notice that I have my q's all on the left side, nothing on the right side. That's good. Now, after I have all the q's on one side, I have this number stuff with the q. I don't want that. I want q by itself. So I'm going to add 7, cancels, negative 5q is equal to 30. Divide by negative 5q to make it positive. So then it will be q is equal to negative 6. Okay. Same thing for this one. I have variables constants, variables, and constants. Move everything to one side. So subtract 6b, subtract 6b. That gives me 0 on the right side because it gets rid of it. 8b subtract 6b, you might write that nicer, gives me 2b subtract 3 is equal to plus 15. Notice now, again, my letters are on one side, but I have a constant of -3. So get rid of this by adding 3, So then cancels, 2b is equal to 18. Divide by 2, b is equal to 9. Okay, so that's that. So for this one, I have variables, constant, and variables. I'm going to move all the variables to one side away from the constants or away from the numbers. So this one is a -6c. I'm going to get rid of this. It's plus 6c. Plus 6c, this gives me plus 2c is equal to 24. Okay, so this cancels that. Now I'm just back to the previous stuff. Divide by 2, c is equal to 12. Simple as that. Let's move on. I think this might be the last two questions. Now it gets a little bit more complicated, involves some of your previous knowledge of math. If I were to give you this part of the question, this is just multiplying. And you need to multiply the monomial to a binomial. Same thing, distribute it. 7 times x is 7x, 7 times plus 3 is plus 21. This is all equal to -21. So notice how I changed that into an equation. And then now I have x's on the left side, no x's on the right side. Well, I'm just going to keep my x's on the left side, but I do have some numbers, so I got to get rid of the numbers by doing the opposite to both sides. Cancels this. This is equal to -42. I still have 7x here, right? Divide both sides by 7 because I have 7 x's. I just need 1, so x is equal to -6. That's it. If you ever want to check this stuff, always substitute this back into wherever you see x. If your left side is equal to the right side, then you're right. If they're not, double check your work. It must be a negative or positive sign issue. Last question, distribute again. So this one is a monomial multiplied by binomial. So -4d, -8 is equal to -4d, well, -8. Look at that. Now I have both sides. I think this is probably a bad question. And why is that? Because if I were to move these to one side, what happens to my variables? Well, they cancel, and then I have nothing left. So basically, I have -8 is equal to -8. Cancel. This is just 0 is equal to 0. This is a bad question because whatever you substitute it in here, you'll just cancel out to having 0. So I think this is a pretty bad question. So I think that concludes, last part is the linear inequalities. So this is similar to your solving equation. Remember, we have signs that are less than, greater than, equal, or less than, or equal to, greater than, and equal to. So this is, it looks like an L, so it is less than. So if you're confused, you can always put this in a sentence like 5 is less than 10. That's what that means. Or -2 is greater than, because this is opposite and less than, is greater than -5. That's what that means. So solve the inequalities. Whenever you solve it for inequalities, it's like solving equations. N -8 or subtract 8 is greater than 4. Plus 8 to both sides, plus 8 to both sides, so n is greater than plus 12. So what that means is that your n has to be greater than 12. So we have two things. We can have one that looks like this, a filled in circle, and one that is a open unfilled circle. This filled in one means that you're including the number, This is where you have your equal sign or greater than, or greater or equal to. This one without filled in means that you're not including, so not including. This is where you have your greater than sign because it doesn't equal to it. So this is n is plus 12, so if you draw 12, it's going to be greater than that, so it's going to be not including 12 but greater than, so that's what you have. So n, the number n is going to be everything greater than 12, so 13, 13.5, 16, da 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 da. But it will never be at 12. It can be 12.01, 12.1, whatever. As long as it's greater than 12, this would satisfy this equation. Next one, subtract 4, subtract 4. This is going to be 3x is less than negative 24. Divide by 3, divide by 3. X is less than negative 8. So we're going to have negative 8 because this is just less than. This is going to be open, smaller. So there you go. And let's solve for these other ones. So this inequality stuff might be a little bit different, but it's very similar to solving for an unknown. So here's one tricky part to this question. Negative 7f subtract 2 is less than 33. So I'm going to solve for my f just like how I would solve for any other question. So negative 7f is less than plus 35. Here's the trick to inequalities. Anytime you're dividing by negative number, like this, you're going to flip this sign. So this becomes a greater than. So f is greater than negative 5. So that's the trick. So this became a, what was a net less than became a greater than. So if it's greater than negative 5, I'm going to say greater than negative 5, negative 4. So I'm going to have like this. Okay. Last two, plus 2a plus 2a. This is going to be 10a minus 4 greater than plus 16. 10a, I'm going to add 4 greater than plus 20. Divide by 10, divide by 10. A is not equal, greater than 2. So greater than 2. This is 2, 3, 1, etc., etc. And then last of all, we're going to go and finish this one. Negative 2m, negative 2m. So this is going to be negative 4m is less than negative 12. Now I need to divide by negative number again. So negative 4. Because of this negative number I'm dividing, my sign is going to switch to a greater than, not positive, greater than negative 12. Oh, hold on a second. I forgot to divide, so it should be positive 3. So m is greater than positive 3. So that means 1, 2, 3, bigger than positive 3. So any number I choose on this line and plug it back in here will make this expression true. So that's the inequality stuff. Hopefully that was a good review. It was pretty brief, pretty fast review. Hopefully that helped you, but if it didn't, you might want to go back to your notes or look at the previous video. That might be a more thorough video. So this is just an exam review video where I'm just giving you guys the answers. Hopefully that unit 4, this unit 4 helped you, and we only have, what, 1 or 2 more units to go, and that's it. So see you later.